2.1 conditional statements. So a conditional statement is a logical statement. It's in if-then form that has both a hypothesis and a conclusion. So here's where I said geometry has a lot of writing. And then this is an example of a conditional statement. It's in if-then form, has if, has a then, and whatever follows the if and just what follows the if is the hypothesis. So in this case, the hypothesis is just you live in Lake Stevens, not if you live in Lake Stevens. So the hypothesis is whatever follows if, and then basically before the comma. Notice the statement does not have to be mathematical. It doesn't have to be geometrical either. And then whatever follows the then is the conclusion. In this case, you live in Washington. In general, in words, every conditional statement could look like this. If P, and then in this case, P would be the hypothesis, then Q. And Q, in this case, is the conclusion. You could also use logic symbols if you're familiar with any logic, like logic uses a lot of symbols, then what it looks like using logic symbols is P, it looks like a ray or an arrow, and then Q. What this means is P implies Q. And then for any conditional statement, you could determine what's called the truth value. So if something's true, if a conditional statement is true, it has to be true for every single situation. If it's false, if you can think of just one specific example where something's false, then that's what's called a counterexample. So if you think about it, if you live in Lake Stevens, then you live in Washington. This statement I would consider true because I don't think there's any other Lake Stevens, like Lake Stevens, Georgia, or Lake Stevens anywhere else in the world. So I would say that this statement is true. If you find, maybe just Google it or something, another Lake Stevens in like the United States or somewhere else in the world, then this would be false. But let's just assume that Lake Stevens, Washington is the only Lake Stevens. So then this statement would be true. So here's another example of a conditional statement. I said conditional statements don't have to be mathematical or geometrical, but since this is geometry, we'll definitely take a look at some conditional statements that have to do with geometry. So if a polygon has three sides, then it is a triangle. You might need to pause if I ask you certain questions, not just for lesson 2.1. Think about them on your own before I tell you exactly what something is. But you need to be able to identify the hypothesis and the conclusion for this conditional statement, and then also be able to determine if it's true or false, or in other words, determine the truth value. So the hypothesis of this conditional statement is just a polygon has three sides. This is the hypothesis. Remember, the hypothesis does not include the if. And then the conclusion is it is a triangle. Or you could also say the conclusion is the polygon is a triangle, because it here refers to the polygon. Keep that in mind when we write certain other things about conditional statements like converses, etc. Okay? And then if you thought whether or not this is true or false, it has to be true. There's no polygon that has three sides. That's not a triangle. So the truth value, or this is true, you can't come up with a polygon that has three sides. That is not a triangle. Okay, maybe you're thinking, well, it could be equilateral. And equilateral is a type of triangle. Well, it could be scalene. Again, scalene is a type of triangle. Every polygon that has three sides is a triangle. So that's the basics of your conditional statements. Again, every conditional statement could be written in if-then form.